In this video, we are going to be looking at circle geometry, and this time we are going to be looking at the rules that involves tangents. So if we have a line that intersects the circle at 2 points, that line is a secant. And if we have a line that intersects the circle at 1 point, that line is a tangent. So here I have my first rule that involves a tangent. And the rule is, the radius of a circle drawn to the point of contact of a tangent is perpendicular to the tangent. So essentially what this rule is saying is that the angle between the radius and a tangent at the point of contact is a right angle, which is equal to 90 degrees. So here I have my first question to demonstrate this first rule. So we want to calculate the magnitude of the angle OAT. So OA is one arm and AT is the other arm, and the vertex of the angle is at A. So OA is one arm, so that's OA here. Then we have AT, so that's A to T is the other arm of the angle, and the vertex is at A. So the vertex of the angle is at A. So this is where the angle is located. And we want to give reasons for our answers. Now, the first thing we notice is that this line intersects the circle at 1 point. Therefore, AT is a tangent. Now we can see that this line here comes from the center of the circle and touches the circumference at T. Therefore, this line is the radius. So the angle at T will be the angle between the radius and the tangent at the point of contact, which will be a right angle. So this angle, the vertex is at T, so the angle will be O to T to A. So I'll have angle OTA is equal to 90 degrees. And how I'll write my reason would be angle between radius and tangent at point of contact. So now we can see that this is a triangle. We have two angles and one is missing. So we know that the sum of the interior angles of a triangle is equal to 180 degrees. Therefore, angle OAT plus 65 degrees plus 90 degrees is equal to 180 degrees. So the 65 plus 90 will give 155 degrees. So I'll have that angle OAT plus 155 degrees is equal to 180. So now I'll carry this positive 155 degrees across the equal sign. I will turn to negative 155 degrees. So I'll have angle OAT is equal to 180 degrees, take away 155 degrees. So now I have that angle OAT is equal to 25 degrees. And your reason for this working would be sum of interior angles of a triangle is equal to 180 degrees. So here I have my second rule, which says that the tangents drawn to a circle from an external point are equal in length. So here I have my circle where OB and OC are the radii. The line AB is a tangent to the circle as well as the line AC. Now notice that these two tangents, they come from an external point, which is A. Just meaning the two tangents intersect at A. Now we can clearly see that the angle between the radius and the tangent is 90 degrees. Also here, between the radius and the tangent is 90 degrees. And this tangent line from C to A is equal to the tangent line from A to B. So here I have the statement that AB is equal to AC, which means the length of the line AB is equal to the length of the line AC. And to write your shortened version of this reason would be tangents are equal in length. And my third rule involving tangents, we have the angle between a tangent to a circle and a chord at point of contact is equal to the angle in the alternate segment. So here we have a tangent that's touching the circle at point B. The line BC is a chord, the line AC is also a chord, and the line AB is also a chord. Now let's look at this chord BC. Now this chord will split the area of the circle into the minor segment here and the major segment here. Now notice this angle X, it's in between the chord and the tangent at the point of contact. And this would be the minor segment. Now notice across in the major segment, we have the angle BAC is also equal to X. Notice that the arms of this angle stands on this chord BC. So we have the chord BC, the angle between this chord BC and the tangent is equal to the angle in the alternate segment, the next segment. And notice that angle must stand on the same chord BC. Now let's just say I wanted to find this angle Y, giving a reason for my answer. Now notice this angle Y is in between this chord AB and the tangent. So this will be the minor segment for this chord AB, and across here will be the major segment. So this is one segment and this is the next segment. So this angle Y, notice this 30-degree angle, the arms of the angle stands on the chord AB, and the angle Y is in between the chord AB and this tangent. Therefore, Y is equal to 30 degrees because this 30 degrees is in the alternate segment. And this is your angle between this chord and this tangent. So I'll write Y is equal to 30 degrees. And my reason would be angle between tangent and chord is equal to angle in the alternate segment.